All right, we're doing this example in class here to solve this 3-variable system of equations. And we're kind of in the middle of solving them the way you've done before with elimination, just on these equations with variables, and kind of at the same time talking about how to turn it into a matrix methods. And using a matrix to solve this is really just like solving with elimination. It is the elimination method, but we're just taking the variables and extra symbols out of the picture. So what we have here are all the coefficients. Each column here, these are the x coefficients, the y coefficients, and the z coefficients. So we've got 2, 1, and 1 there, 2, 1, and 1 there. 1, 3, and 1, 1, 3, 1, negative 1, 2, and 1, and then 2, 1, 2. So that's what those represent. And if you think about the elimination technique, what you're trying to do is you're trying to eliminate those coefficients, right? So my advice on any 3x3 system, the first thing you want to do is try to eliminate the same variable 2 different ways. And you got a lot of options here. If you don't care where you're going to get your zeros, you could do it with x, right? You could do like row 2 minus row 3. You could do row 1 minus 2 row 2. You could do row 1 minus 2 row 3, right? Any of those would eliminate x. So pick 2 of those basically, right? You could eliminate y 2 different ways. You could do row 1 minus row 3. You could do row 2 minus 3 row 1, or row 2 minus 3 row 2. Or sorry, row 3 row 3. Anyway, lots of different ways, right? The zeros here. That's like the way. I'm going to go with that. But if you did it a different way, that's fine. What we're doing are called row operations, and that's basically just the stuff where you do combinations of one equation with another. So if I say row 1 minus 2 row 2, that's a row operation. Okay, so this matrix is exactly the original system, right? And so what I'm going to do is in my next step, I'm going to do row operations. And what I'm going to do is I'm going to get a 0 here. The way I'm going to do it is I'm just going to do row 1 minus 2 row 2 to get that 0. And when you do this, you want to label your row operations so that it's clear what you've done. And that way, if you make any mistake, you can kind of go, it's possible to go back through and find it. I will say the arithmetic on these is not that hard, but you want to be careful because one mistake screws up the whole thing, right? That's the downside to these. And in the long run, the goal isn't to really do these by hand. We are going to do them by hand because we're learning the process. But the idea is you understand how it's done, and then you have machines do it for you, right? The whole point of matrices is to have machines do it for you. But you need to know how it works if you're going to do that well. All right, anyway, I'm going to do the exact same thing then for row 3 to get a 0 here. I could do row 1 minus 2 row 3, or you know what, it might be easier to just do row 2 minus row 3, right? That looks a little easier. So I'll do that there. Row 2 minus row 3. I'm being a little inconsistent here. I feel like I usually do subscripts for those numbers. Here I didn't, whatever, it doesn't matter. However you like. Also, let me just mention you can do in between steps too. If you want to do like 2 row 2 first and then do row 1 minus row 2 in the next step, you can do that. It's just a lot more writing. If you practice kind of doing this all at once, I think you'll get good at it. If you want to use, I think this is a test where I would let people use scientific calculator when dumb arithmetic mistakes, So if that helps you make not screw up, 1 minus 2 times 3 or something, be my guest. All right. And then one more thing, sorry, before I go through with this operation. When you're doing row operations, the big rules, every step that you do, every new matrix has to include all of the rows from the previous matrix. So you don't want to do row operations that totally leave out a row. So for instance, I'm going to just leave row 1 as row 1. And then one way to make sure that you do that thing I just said is that when you write your new row 2, make sure that the row operation includes row 2 from the previous one. And when you write your new row 3, make sure that it includes row 3 from the previous one. If you do that, then you won't leave any rows out. And the only other thing you got to be careful of is don't do the exact same row operation for 2 rows. Okay? The idea is either of those things, if you screw up one of those things, you will lose information from one matrix to the next. As long as you keep every row from one matrix to the next somewhere in the operations, and you don't do the same operation twice, you will not lose information. All right, so row 1, I'm just keeping the same. 2, 1, -1, 2. In row 2, what I'm doing is row 1 minus 2 row 2. Row 1 minus 2 row 2. All the way across, I'm going to do that. Okay, and what I'm really doing is this equation minus 2 times this equation, right? That's the algebra. You've done that before. We're just kind of simplifying it here. All right, so 2 minus 2 is 0. That was by design. I'm getting the 0 there. Then I've got 1 minus 2 times 3, so minus 6. That's going to be -5. Then I've got -1 minus 2 times 2, so that's -4. -1 minus 4 is going to be -5. And then I've got 2 minus 2. That's 0. Okay, that's my new row 2. Okay, and again, it's like a little uncomfortable at first, but it's all like the math's easy, but you're mapping out what you're going to do here. So if you ever forget, look back at this and just kind of go up. And once you get in the habit of it, it's not bad. It gets easier because you kind of, it's a process that you get used to. All right, the next one I'm doing is row 2 minus row 3. So row 2 minus row 3, 1 minus 1 is 0. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 2 is -1. Good? Okay, now what I have is a 2 by 2 system. What I mean by that is this bottom 2 rows here represent 2 equations, and both of them have 0 for x, so that means they just have y and z. You can now solve that as a 2 by 2 system, right? But I'm going to keep going with the matrix. And again, the standard for the matrix method here would be to get a 0 here next. Okay, now you might be inclined to get the 0 here because it looks a little easier, and that's fine. That'll still solve the problem. Okay, we'll talk about more specific instructions down the road. Like if I tell you, get the matrix into reduced row echelon form, when we'll talk about that, then you have to get the 0 there first, whatever. But like if it just says solve using matrix row operations, you could pick to do it here, and that would be okay. I'm going to go with the standard though. So what I'm going to do is set up my next matrix. And row 1, again, I'm just going to leave alone. Row 1 is fine. I'm not trying to do anything to row 1 right now. Row 2, I could leave alone, but there's one thing I can do to row 2 here. What could I do to row 2, do you guys think? That would just... Spence? By 1, right? Remember, it's an equation. This whole line is an equation. So we could multiply it by -1, and then it would be 0, 5, 5, 0. That would be better, right? What else could I do? Not just -1, but a fifth. It's just an equation, so we can multiply both sides by -1/5, and then it would be 0, 1, 1, 0. Would that be a lot simpler? I'm going to do that. I'm going to do -1/5 row 2 for it. And in fact, I'm going to do it right away. Before I do anything else, I'm going to write down row 1 and -1/5 row 2, because I think it might help extra thinking and maybe another step with the matrix. You can row 3 alone for right now. You could row 3 and do the next step, because now, isn't it going to be a lot easier to get that 0 there? You won't have to think as hard. You know what I mean? I don't have to do 2 times this plus 5 times this, because now I have a 1 here. You know what I'm saying? So if it was me doing it by myself, what I would do now is I would say, okay, -2/5 row 2 to make that a 2, and then, minus row 3. But I'm going to go ahead. I don't want to make this overly confusing for the first example. So I'm just going to keep row 3 here for now and do this as like an intermediate step. Now I'll do that row operation. So again, row 1 is going to stay the same. Row 2 is looking great. I'm going to leave that alone. And then for row 3, I'm going to do row 2 minus row 3 from the previous one. Okay, that way I'll have positive numbers in the third and fourth columns. That's what I was thinking about there for a second. So I'm going to do row 2 minus row 3. Now, if you did row 3 minus 2 row 2, that's also fine. You'll just get negatives where I'll have positives, but it'll all come out the same at the end. All right, so 2 times 0 minus 0 is 0. 2 times 1 is 2, minus 2, that's 0. That was by design. 2 minus 1 is 1. And 0 minus negative 1 is positive 1. You guys with me? Cool. Okay. We're ready to solve now. We're going to plug stuff into back substitution. There are more things we could do in matrix. We don't need to get into all of that yet. If we're just trying to solve the system, it's probably easy to just plug it in right now. So before I do that, I just want to point out one thing that I thought of while I was doing that step that might cause issues for people. And that is right here where I did row 2 and row 3 together to get the 0 here, right? It's really important at this step when you're trying to get this 0. It's really important that you do row 2 and row 3 together now. You do not want to use row 1 at this point. Why? What would happen if I used... Yes. If I used row 1 with row 3 to get this 0, I could do it, right? I could do 2 row 1 minus row 3, and I would get a 0 here. But what would I get? I would screw up that 0 down there, exactly. 4 minus. So you have to use these two rows together because they both have the lead 0. It makes sense if you think about it. Go back to the equations. What we said at this point, we have a 2-variable system, right? 2 equations with 2 variables. That's y and z. That's what we're doing. We're using those 2 equations. You can't use them. It's got 3. You know what I mean? So that's what we're doing there, right? And so we've got our zeros in diagonal here. You kind of know you're at this point where we can solve. And so now it's really easy solving. Check this out. Plus 0y z equals 1. That means z equals 1. Does that make sense, everybody? X plus 0y plus 1z equals 1. That's what that row says. Okay? The next row says 1y plus 1z equals 0. So what's y? Well, yeah, z's 1. You can plug it in. Y must be negative 1. And then the first row, now you go into there. This is called back substitution, what we're doing now. 2x plus 1y. You can even just plug in the negative 1 for y. And then minus 1z equals 2. Simplify that. So we have 2x minus 1 equals 2. Add 2 to both sides. 2x equals 4. X equals 2. So our solution is 2, negative 1, 1. Did a lot of you get that? Okay, cool. Yeah, that one wasn't supposed to be. So if you got it, great. If not, you probably made one little mistake somewhere that just compounds throughout it and messes it all up. That's okay. It's about the process. If you're understanding the process, we're in good shape. I'll put up another one here in a second, and I'm really going to encourage you to try to use the matrix approach this time, okay, to practice doing that. So that is something we have to learn.